Hi there, I'm Dr. Nate Storey from Bright Agrotech, and this is Aquaponics Academy episode number 11. Today we're going to discuss the ins and outs of media-free aquaponic and hydroponic systems, and we're going to talk about whether or not they're a good fit for you.
Welcome to Aquaponics Academy, a Bright Agrotech podcast designed to help you overcome common aquaponic issues, learn new growing techniques, and help you be as successful as you can be as an aquaponic practitioner. Join aquaponics expert Dr. Nate Storey, the creator of Zip Grow Towers, as he breaks down complex topics into easy-to-understand information. And now, here's Dr. Nate Storey.
In the last podcast, I went into a detailed discussion on the basics of media-based systems. And we went into detail on the types of media-based systems out there and the different ways to plumb them up. And we also kind of went into my recommendations on the crops that you can grow in those different types of systems. Which crops are better, which crops are not suitable. I also chatted a little bit about about specific surface area. And we talked about biological surface area and the differences between biological surface area and specific surface area. And today, as we talk about media-free or media-less systems, it's really important that you still keep all of that talk about specific surface area and biological surface area in mind. So if you haven't listened to episode number 10, I'd definitely go back and check it out, along with some of our videos on biological surface area and specific surface area. I think they'll help shed a lot of light on what specific surface area really is, how to calculate it, and why it's valuable in this discussion. Today we're going to talk about media-free systems. This is typically raft, aeroponic, and occasionally people will lump NFT into media-free systems as well. And they consider NFT a form of aeroponic production. Many growers do, at least. And we're going to talk about the nuts and bolts of these types of systems. We're also going to discuss whether or not they're the best system for a beginner. That is, someone who's just starting out. Do you really want to leap into aeroponics? You know, that's something we're going to talk about. So before we get going too far here, I'm going to just talk about what I mean when I say media-free systems. When I say media-free systems, what I'm talking about are systems that do not have a growing medium in them. So you don't take the plants and you don't, instead of planting plants in hydrogen or crushed granite or Zip Grow matrix media, something like that, the roots are basically hanging freely either in water or in air. And typically, there are only a few systems that are really considered media-free systems. And a couple of them are very common in aquaponic systems. And so next I'm going to chat a little bit about types of systems out there. Raft and deep water culture systems. Same thing, just kind of different terms used to describe the same thing. Basically, these are a big tank of water, and the plants float in floating rafts on top of this water. And the roots dangle down into the water, and of course they take that water up and they take the nutrients out of the water. And so this is one type of media-free system or media-less system. So Raft and DWC systems are very, very common in commercial aquaponics setups. And if you've listened to the previous podcasts, you know that I talk quite a bit about raft systems, mostly kind of in the context of what we do with Zip Grow Towers. So it's a very common method. It's very inexpensive to get started relative to other techniques. And you have you can grow a lot of very common and relatively valuable food crops using DWC. So it's not a bad way to grow. It really is not. So if you're getting started with aquaponics or hydroponics, and you're looking just for a really inexpensive way to grow, kind of a hobby level, raft is not a bad way to go just because it is so inexpensive. Now, I will tell you it does not scale very well, so the cost of labor becomes pretty tough on most commercial growers as they scale with raft. But, as far as just a cheap way to get going, it's not a bad way to go. One of the nice things about Raft is that it's got a lot of thermal mass, and it started down in the south, and it started kind of in tropical areas where it got very, very hot during the day. And if you know a bit about plants, you know that fluctuations in the root zone temperatures are very bad for plants. So what we want to see is we want to see that root zone staying nice and cool in the heat of the day. And if we keep that root zone really cool, if we can keep those roots cool, then oftentimes our plants can keep growing. And they actually do pretty darn good, even when the outside temperatures get very hot. Now, this is kind of a strange thing, and most people don't understand it. So when they see their plants slowing down in the heat, they think it's because, because it's so hot outside. Well, that's only half of the truth. The reality is it's because those root zones are oftentimes heating up. Now, there's definitely kind of optimal temperature ranges for most crops, but a lot of the time you can get better production in very hot environments if you can keep the root zone cool. So rafts are very good at doing this, and this is one of the reasons why they were very popular, especially in kind of tropical areas, because the cost of labor was low, and so it didn't matter that they required more labor to produce the crop, because the labor costs were low to start with, and they also kept the roots really nice and cool. So it's not a bad technique if you're in the tropics or if you're in a very hot place. Raft or DWC can be a great way to grow. NFT is another technique, and that stands for nutrient film technique. And this is another media-free technique. There's no gravel, there's no hydrogen, there's no media in the system besides the plug that you start the plant in. So these are plants that get started from seed in plugs, and basically we drop them in these troughs, and we're irrigating these troughs at one end, and the water is flowing down the entire length of the trough and dribbling out the other end, and we're capturing it and recirculating it. Or in some systems it's float away, so they just let it dribble on the floor. I don't necessarily like that, but it's how some things are done. So NFT has a very thin film of nutrient solution that runs down the bottom. It's not deep at all. It's very, very thin, and those roots kind of expand into this mat along the bottom of the trough, and that's why it's called nutrient film technique. Because there's just a very thin film of nutrients that run over this mat of roots that are kind of growing in the bottom of the trough. Well, a lot of people also consider NFT to be a form of aeroponics because the roots usually hang down just through the air into this film. And so it's kind of half hydroponics in the traditional sense and half aeroponics, which is kind of the next technique we're going to talk about. Aeroponics is the culturing of plants with the roots hanging in the air. So essentially, the roots hang in the air and they're misted, or water is dripped or misted over the roots. Misting is the best way to do it, and it's primarily done with misters because plant roots don't tolerate too much force. That is, water dripping on them, being splashed or moved. Most of the plant roots are what are called hair roots. These are teeny tiny, itty-bitty little microscopic roots that you can't see unless you get out a microscope or a magnifying glass. And if you look carefully with a microscope or a magnifying glass, you'll see all these teeny tiny, itty-bitty little root structures that stick off of the main roots. Well, in aeroponics, when we mist those roots, those water droplets land, they're very small and they land fairly gently, so they don't snap off those hair roots. But if you are dribbling water over the plants kind of roughly, they'll still grow, but your growth usually isn't as good. And the reason for that is as the water flows over those roots, it can actually damage those hair roots. It can damage the smaller roots on the plant, which of course slows the plant down. It means it doesn't grow quite as fast as you want it to, or as it could be growing. So it's something to keep in mind. Something to think about. Now, the big drawback of NFT and aeroponics is that the root zone temperature that I was talking about earlier, one of the benefits of raft production, of course, is the thermal mass, keeping those root zones cool. Aeroponics does not have the benefit of all of that water holding heat or keeping those roots cool, right? So in these systems, and if you do not control the temperature, what can happen, because the temperature of air can change very quickly in relation to the temperature of water is that you have the root zone that it heats up. And as it heats up, those roots start to suffer. And they start to suffer for a few reasons. One is dissolved oxygen, which I'm going to talk about in a little bit. But a lot of it is they just do not like that change in temperature. And, if you're dealing with aquaponic systems where you already have solids, lots of solids, as your temperature rises, your dissolved oxygen gets lower. So oxygen is less soluble in water as water warms up. So that means as those root zones warm up, there's less oxygen available to the roots. Maybe there's solids decomposing, and those are consuming oxygen, and pretty soon you've got disease issues, and you've got dieback, and you've got really, really unhealthy plants on your hands. And it's all because they just did not have a way to keep their roots cool. The grower didn't keep the roots cool either through managing his temperatures or managing his solution temperature. Now, this was something we were really worried about initially with zip grow towers is root zone temperatures. But what we found is that we cycle enough water through the towers that if we're cooling our water, we can actually keep those root zones very cool, even on very hot days. And we have not had any problems. It actually works pretty well for us. So thinking about root zone temperatures is really important when we're talking about these different techniques and where they're appropriate. Now that's why oftentimes you'll see raft or deep water culture, DWC techniques in the tropics and the south. And as we move north, you're going to find fewer and fewer growers that use those. Almost everyone is going to be using NFT for producing basil, for producing lettuce, all these other crops, because NFT is more space efficient than raft or deep water culture, and it's also much more labor efficient. So that's why in these media-free techniques, you'll see NFT and these types of techniques in the northern U.S. and Canada and kind of the Midwest, and you'll see raft and DWC in the south, where it gets very, very hot. And cooling is more of a problem than heating. One thing about media-free systems is that you need to provide filtration, especially for aquaponic systems, right? Because you've got all these solids, and you've got to get the solids out, or they're going to collect on plant roots. And in a lot of these techniques, that's kind of a death sentence for a lot of plants. So there's a few different ways we can accomplish this. The most common ones are through settlement or somewhat passive kind of filtration. And, cyclone or swirl filters kind of fall in this category. Settlement tanks, so tanks where the water is moving slowly and the solids can just sink down to the bottom and be removed. These are kind of settlement or relatively passive solids removal techniques. Then we also have mechanical filtration. So these are kind of mechanical means of removing those solids. And in this category, I would lump things like polygeysers or bead filters. These are things where the water is kind of pushed through this contraption. It's full of beads, and it's actively kind of removing those solids from this pressurized water flow. And those can be very handy, but they do require that you operate. It is required that they operate under pressure. So it's kind of a big design question. Which technique are you going to use? What type of solids removal do you need? How are you going to integrate it into your system? But all of these different techniques do need some form of solids removal. And trickling filters, that zip grow towers are kind of a kind of trickling filter, but there are lots of other trickling filters out there where basically you're taking solids-rich water and you're just kind of dribbling it down through this media, and the media itself removes the solids. This is a lot like a grow bed in a media-based system, okay? So that's functioning basically as a trickling filter of sorts. And of course, all of this is just removing solids. Biological filtration is also necessary. That is, using bacteria to convert dangerous compounds to capture some solids, so they're capturing things in the water, and they're converting a lot of, say, ammonia to nitrite, and they're converting nitrite to nitrate. Now, things like polygeysers or things like bead filters will actually do a lot of this for us. because all the little beads in there are colonized by bacteria, and as the water passes through, they're oftentimes nitrifying or mineralizing different things. So bead filters, polygeysers, these types of filters can be very useful in like Raft and DWC systems for getting all the solids out, as well as NFT and aeroponics. Now, the thing to remember about NFT and aeroponics is that it's important to remove solids in everything, but if you're going to be misting this water, you have to remove pretty much all of those solids before you mist that water. So you have to keep in mind the level of filtration that you need to apply to these different systems, and know that if you're going to grow aeroponically, you better remove all of your solids from your solution. So as we're talking about all of this stuff, again, it's very important to remember the trade-off between cold and warm water when it comes to dissolved oxygen concentrations. The colder the water is, the more dissolved oxygen is in the water, right? The more oxygen can dissolve. So that usually means that cooler water is healthier for roots within a certain temperature range. So if plants like a range between, say 55 degrees and 65 degrees, if you really want to maximize the oxygen at the root level, if you have a lot of solids in your system, you want to run your system a little bit cooler. And that's going to help make sure that those solids that are decomposing in the root zone are not consuming too much oxygen. They're not making anaerobic conditions for the plant roots. Now, I will say, in most aeroponic techniques, it's pretty darn tough to get to go anaerobic. But decomposing solids are not a good thing, and it's amazing that even in NFT systems where there's so much air and so little water, you can really have anaerobic root zones even still, and you can have root dieback due to temperature and lack of dissolved oxygen, even with that huge concentration of air. And a lot of that has to do with just solids that collect in that trough. It's amazing how much can collect there in very little time. And of course, on the very bottom there, as it decomposes, it consumes a lot of oxygen. So you have to kind of keep all of this in mind as you're thinking about it. And of course, if you're doing Raft or DWC, you will have to actively be aerating your tanks and keeping those tanks well aerated, keeping those oxygen levels high, removing those solids, and making sure that you're protecting your plant roots from anaerobic conditions. The microbes in these systems are a little bit, you have to be more thoughtful about them than you do in media-based systems. And that's mostly because there's just a lot less biological surface area in the system by nature of design. So with all of these systems, because we don't have all of this structure, all of this aggregate, all of these fibers for the microbes to settle on, we actually have to supplement that and provide bird netting or something similar for the microbes to live on and do their thing. So almost all these systems have what are called mineralization tanks. If you're doing aquaponics, you have to put in a mineralization tank, and this is just basically kind of a biofilter where the microbes live on pieces of plastic or an aggregate of some type, or most of the time the most common thing is bird netting. So they'll just go buy a bunch of bird netting and they'll kind of wad it up and stick it in a tank. And the water flows very slowly through this tank, and through this bird netting, it removes a few more solids, and it allows a lot of those solids to be mineralized. That is, different compounds in the water to be oxidized, and it allows for a lot of plant nutrients to be released from all of these organic compounds. So not all of those processes are aerobic, but most of the aerobic ones do happen in the mineralization tank. So having a mineralization tank is necessary in these systems just because you don't have quite as much biological surface area that is long-term, that is steady, that is not being disturbed, like you do in media-based systems. Now, a lot of folks will say, well, plant roots are great biological surface area. All these roots, all these little hair roots, there's a lot of specific surface area to that. And the answer is yes, of course. That's absolutely true, but you also have to remember that it takes a long time to establish that bacteria. So every time you go in and harvest and remove those roots, and every time the plants are then, the new plants are growing new roots, you have an entirely new establishment period. So what this means is that we have to supplement supplement the biological surface area of the system with a mineralization tank or with some other biofiltration device. And that could even be something like a bead filter or a trickling filter. So when it comes to crops in media-free systems, we're a little bit more limited. In media-based systems, we can grow almost anything. But in media-free systems, we're stuck with typically relatively short-statured crops. These are plants that don't need a whole lot of anchoring to grow. So we're not talking about tomatoes. Tomatoes will need a media because they're long and they're vining and they need a lot of anchoring for their roots. We're not talking about zucchini or eggplant. We're not talking about crops that kind of grow a little bit larger in stature. Typically, we're talking about lettuces, greens, and short-statured herbs. These are the things that grow best. Now, you can grow other things, but remember that the larger that root system gets below those rafts, the more air you have to supplement, the more oxygen you have to supplement, and the more you have to watch your solids, because large plants consume a lot of oxygen. Small plants don't consume quite as much. So if you're growing in a relatively shallow raft, or if you're growing in a raft with a little less volume and you're growing these big plants, the possibility of consuming all the oxygen in that water, if you're not moving that water fast enough and you're not actively aerating, becomes much, much higher. So it's kind of playing with fire when you go over to large statured plants with really extensive root systems. So please keep that in mind. If you consider growing with raft or NFT or aeroponics, definitely stick with shorter statured crops. They're easier to manage, and it's just much easier to grow large statured crops in media-based systems. Also keep in mind that media-free systems, with the exception of some hydroponic systems, are usually a little bit lower nutrition than systems where the media is capturing the solids and those plant roots have access to those solids as they're being mineralized. So, for instance, in zip grow towers, the towers themselves end up capturing lots of solids. They build up in there. They kind of compost, decompose. The worms are working on them. And there's just a lot more dense plant nutrition in the root zone. Similarly with media bed techniques, so you've got a 3/4 inch crushed granite bed. All those solids kind of get captured in that rock. And as they decompose, they provide a lot of nutrition to the plants. In these media-free systems, because we're removing many of these solids, it doesn't mean they're poor nutrition. It just means that the nutrition is not typically as dense in the root zone as it is with media-based systems. So please keep that in mind as you're doing your design. So think about that. You can grow just about anything in raft systems or in NFT systems, but not everything is appropriate. It's not always the best choice to grow some crops in these systems. So when you're thinking about these systems, it's really important to think about aeroponics and some of the problems that aeroponics presents. So if we're talking about misting plant roots, then all of a sudden we know that aquaponic production is probably out, right? Because the irrigation needs of that system are very high, and it can be very difficult to get really well-filtered water that will mist all day and not foul with all these little microbes and fungi and algae. This is very hard to accomplish in aquaponic systems because they are so living, because they're so active, because there's so much biology there. Things biofoul, and they foul up very quickly, and you stop up sprayers, and once the sprayers stop up, the plant roots die. So it's important to think about the irrigation and the drainage you're going to be using. Aeroponic systems, they mist those roots. The water is captured down below and recirculated. It's appropriate for hydroponics. It's not appropriate for aquaponics. It's not to say it can't be done. It's just to say that you're going to spend a lot of time and you're going to suffer an awful lot to find any success that you could easily find with another technique. NFT is a little bit easier. You can run a little bit, you can run more solids in NFT systems. You don't want to run very much. Remember, those solids can accumulate in that root mat, and you can have you can have kind of decomposition and the potential for aerobic conditions or anaerobic conditions. So keep that in mind, and think carefully about how you're irrigating your NFT. There are certain flow rates and there's levels of incline. You want to make sure you're checking on those. Make sure your water's not moving too fast or too slow, and make sure that you're kind of controlling the temperature of your water. And running cooler water is going to help reduce kind of the negative effects of having all of that air in your troughs. So think about that. Think about chilling your water. Think about cooling it off before you run it to your plants in your NFT troughs. Usually you're not irrigating at a very high rate with NFT, and it's much like towers. Growers will go around and they'll check their drippers every single day, maybe a couple times a day. They'll look for wilting, make sure things aren't clogging up, and by and large, they can grow pretty successfully, and the irrigation and drainage isn't too much of a pain for them. With DWC, when you're thinking about irrigating your crops, you want to try and figure out what the happy medium is between moving too much water and really having those roots waving kind of in that water flow. That's not ideal because, of course, you're damaging those roots. But you kind of want to split the difference between that and supplying too little water and having either nutrient depletion from one end of your DWC trough to the other, or having oxygen depletion from one end of your DWC trough to another. And this is very common in a lot of DWC systems, especially at the very end. So usually people will be dumping water into one end, and it will flow down the entire length of their DWC bed or trough to the end where it drains. Well, as it goes, it's kind of pushing along these solids. So oftentimes at the very end of their trough, you have solids accumulation, which can really impact root health. And you also kind of take into account the fact that oxygen is being consumed the entire length of that bed. And at the very end, you can oftentimes see dieback, root dieback, or poor plant health as a result. So think about how you can design your DWC troughs to collect solids somewhere in the system, for them to be flushed or removed somehow. And don't make them too long, or you can see nutrient and oxygen depletion effects on your crops. So the last part of this, I just kind of want to talk about media-free systems and our experiences with them. We've tried a few. I've tried a few different aeroponic techniques, NFT and DWC, and they can be very useful techniques. Sometimes they're typically pretty lightweight, at least the aeroponic and the NFT types are, which is nice. They're fairly easy to assemble and get going with, and they're not typically really expensive. Some of the aeroponic and NFT techniques are certainly more expensive than DWC. DWC is really inexpensive. But the thing you really want to think about is designing a system for your needs. So taking into account what I said about crops, taking into account what I said about labor, you want to be thinking about these things as you're putting them in. Like I said, we've tried them all, and anymore, all we ever use really is zip-grow towers, because our markets mostly want crops that grow well in zip-grow towers, and there's no other reason for us to grow in DWC troughs or NFT troughs or anything like that. And the fact that we can do live sales with them suits our markets very well. So that's the direction that we've gone. And so think about all that stuff as you're getting set up. And I will tell you that, for most beginners, you don't want to start off with these techniques, with the exception of maybe DWC. DWC is worth messing with on a small scale because it's cheap. I mean, if you're operating on a budget, you can make basically a DWC raft system out of an air stone, an aquarium air pump, and a Tupperware container or a bin. So it's accessible, right? But, in the end, we've kind of graduated from all of these techniques, and we find that for beginners, using some type of media-based technique is usually the best route to go. So DWC is inexpensive, but it is kind of tricky, and it can be a little bit difficult. And if your air stone goes out, you can have a lot of dead plants. Whereas like an IBC system with 3/4 inch crushed granite is pretty much foolproof, and you're going to have a lot of success. You've got a much broader crop range that you can grow and enjoy, and it's really not that much more expensive, and certainly a heck of a lot easier than growing with a DWC bed. So if you're just beginning aquaponics, look into zip grow towers, look into media-based growing techniques as kind of the best way to get started. Because a lot of the time it will end up being a lot more simple for you than if you just tried to get going with one of these media-free techniques. So that's just my 2 cents on beginners and whether or not you should be starting with media or media-free techniques. If you have any questions about this, definitely go back and listen to the webinar I did on different types of systems. It was a podcast, I guess. It was several podcasts ago. Go check that out. And I talk in more detail about the different techniques out there, what they're good for, and why you should be using them. So that's about it for this episode of Aquaponics Academy. Thanks so much for tuning in. If you're a regular listener, you know that with every Aquaponics Academy episode, we help you learn new techniques, overcome common obstacles, and grow your aquaponics and hydroponic systems. We also introduce thousands of other listeners to clear, demystified, and what we think are really valuable resources for the beginner to the advanced grower. And you can find them all at our website. That's brightaggrotech.com. If you do find these podcasts to be valuable, please consider leaving a tip on our podcast website to help us continue producing these episodes. And if you're not a Bright Agrotech customer yet, we definitely encourage you to check out our incredible product line at zipgrow.com. That's zipgrow.com. Thanks so much for tuning in. We'll look forward to the next podcast, and hopefully we'll catch you next time for another episode of Aquaponics Academy.